Okay, hello everybody. Today we'll be reviewing for the first semester. So, since you probably have midterms around this time as well. So, let's start off with stoichiometry, right? Because this is like one of the basics of chemistry as well. So, we're given that a sample mixture containing CuO and Cu2O has a mass of 1.512 grams. And when this sample is reacted with excess hydrogen gas, 1.275 grams of copper metal is formed. So we're trying to figure out the mass percent of CuO and Cu2O in the original mixture. So the first thing we could do when dealing with this type of problems is you could write a chemical equation for it. Okay, so we know that before the reaction, the sum of the CuO and Cu2O is just 1.512, right? 1.512 grams. And Cu, after the reaction, the amount of copper that's created is 1.275 grams, right? So we know like for sure to find the percent by mass of CuO and Cu2O. First of all, we have to figure out the individual grams, how much grams occupy CuO and Cu2O, and then divide by the total mass. So we find the number of grams of CuO and then divide it by 1.512 to get the percent mass of CuO. So we could write an equation for that. We could write that X number of moles, since we don't know the number of moles of CuO, X number of moles of CuO divided by its multiply by its molar mass, and multiply by its molar mass, which is 79.55 grams. 79.55 grams would give us the total number of grams of the CuO. Plus, since we don't know the number of moles of Cu2O, we say Y number of moles of Cu2O Y number of moles of CuO multiplied by its molar mass, which is 143.1 grams, would give us the total mass of the substance, which is 1.512 grams. 1.512 grams. So essentially, if we could find the amount of moles of CuO and Cu2O, we could essentially solve for the problem, because we could then figure out the number of grams of CuO and then divide it by the total mass, which is 1.512. And also, since we know that X moles of CuO has X moles of Cu, because if we know the total number of moles of copper inside the original substance, we know that total number of moles of copper before the reaction equals the total number of moles of copper after the reaction, because of conservation of, well, in this case, yes. So since we know that the number of moles before the reaction equals the number of copper, just copper itself, equals the number of moles of copper after the reaction, we could write that X moles of CuO, which just, we could figure out the individual number of moles of copper just inside CuO, which is X moles of CuO. So X moles of Cu is in X moles of Cu is in X moles of CuO, and because it's a 1-to-1 ratio right here, right? And we know that Y moles of Cu2O has 2 Y moles of Cu because it's a 2-to-1 ratio. So knowing this, we could say that 2Y moles of Cu plus X moles of Cu, which is the amount of moles before the reaction, equals the number of moles after the reaction. And we could find the number of moles of copper after the reaction because we're given the mass of copper after the reaction. So we could just find the number of moles of copper after the reaction, and then equal that to 2Y plus X. Okay, since we know that after the reaction, number of moles of Cu is 0.02 moles of is 0.02 moles, we could say that 2y plus X equals 0.02. So knowing that 2y plus X is 0.02, we could substitute a variable for, let's say, X. We could substitute a variable to plug into the function. Like for example, we could solve for X and then plug that value into this function right here. So you could say 0.02 minus 2y equals X, and then use that variable to plug it into this equation right here to solve for the number of moles of each substance. Okay, so knowing that information, you could substitute this variable with X, and then afterward you could solve for Y, and then you'll get that after solving for Y using this equation right here, you'll get that Y would equal to 0.00525 moles, right? 525 moles, right? And then you could plug that into this function right here to solve for X, and you'll get that X would have to equal to 0.00995 moles, right? And then since we, from our equation here, we associated the variable X with the X number of moles of CuO and Y for the Y number of moles of Cu2O, we could just then solve for the number of grams of CuO using X, which will be which will be 0.757 grams, 55.7 grams of CuO, and then Y. Well, you only need one variable, because then you could just subtract that by 1.52 to figure out the number of grams of the other variable. So we know that 0.5. So we could find the percent by mass of CuO, since we know that there's 0.7557 grams of CuO in the original mixture, and that the total mass of the two substances is 1.512. So you could write 0.757 grams. Sorry about my handwriting. Divided by 1.512 grams of the whole mixture would give you a percent of 49.4%. 49.9%, which you could just estimate to 50%. So knowing that there's 50%, of CEO, right? We could obviously figure out the number of percent of Cu2O, which is just 50%, because you just take you take 100 and subtract it by 50, and you'll get 50. So it's pretty simple. Okay, thank you. This was Fall Academy. I hope this was very helpful for you to understand what stoichiometry is and like the gist of it. So let's say instead of giving you the grams, they give you the percent. You could assume that you have a 100-gram sample, right? And then 100-gram sample of the whole thing, and then just use the percent and convert it to grams, and then figure out the moles of that. Fall Academy signing up.